All right, before we get to naming ionic compounds, we need to settle a few things with charges. And so on this periodic table, for an ionic compound, anything that first column is going to have a +1 charge. Anything in the second column is going to have a +2 charge. Our halides in an ionic compound over here are always going to be -1. And then we have a few symbols that normally I would ask you to memorize. You just want to know this or have this some way that you can get a hold of it while you're working on the problem. So the first one here is silver. Silver is right here. Ag+. The next one is zinc. Zinc 2+. Next one is cadmium. Cadmium's right below zinc. Cadmium 2+. And then aluminum, which is up here. Aluminum 3+. So you either need to know this or have this handy when you're working through the exam. So these guys here are the first column, the second column, and the ones that I've indicated here are constant charge ions. In any ionic compound, it's always going to be zinc 2 or cadmium 2 or silver 1 or aluminum 3+. Now everybody else that's in here, all of the other elements, and my favorite element, the one that I work with, 1, 2, 3, 4, 5, for example, iron, common oxidation states of iron are common charges for iron are iron 3 or iron 2. And so you're going to have to put in a little bit of extra work to figure out what the charges are. And this is a simple one to show. So for example, FeCl2 versus FeCl3. Well, we said whatever's here always has a -1 charge. So there's 2 chlorides, each with a -1 charge. So in this top case, it's iron 2. And then here, there are 3 -1 charged chlorides. So in this case, we would have iron 3. And both of these can be made in a chemical factory and put into bottles. And so this is a real compound, this is a real compound, depending on how it was prepared.